Good evening, everyone. My name is Rajat Bonik. I am a PM and research scholar at IITM Dhanbad. Today is our last class in this course, and today's class is our extra class. We already covered all the lectures, whatever taught by Professor Dilip Murabhedro in his Nptel. This class is going to be a revision class of all the lectures in short. So we will start our class at 6:05. I we will wait 5 minutes for to join others. Then I will start our today's extra class. So please stay on the line. I will be joining at 6:05. So Let's start our today's session. Good evening, everyone. My name is Rajat Boni. I am a PhD and also a PMR research scholar at IIT Dhanbad. I am a TA under Professor Dilip Kumar Vaidya sir for this ground improvement course. Today is our last class, and this class is one extra class uh, where I am going to discuss all the lectures in short, whatever all the 12 lectures in short. So this class is a revision class, and also two or 3 points I mention here that this video is recorded and it is uploaded on my YouTube channel. You can access through it, and whatever I am discussing here, I or material, it will be shared to everyone through my Google Drive. And if my network is cut or my line is cut, please don't worry, stay on the line. I'll be joining in very few minutes. So let's start our today's session. Uh, I think it is going to be a last one. So let's start. I'm sharing my PPT. I'm discussing all the 12 lectures one by one. It is going to be very large. So I am trying to keep it very simple and small. So please cooperate. I'm sharing my screen. I think it is visible to everyone. Uh, uh, so yes, so let's start our session. So in the beginning, we study the ground improvement, why we need this ground improvement techniques. So here, few points are made that the like other material, soil is also a civil engineering material, and it is need improve because the it is soil formed naturally and properties mostly not known or dependent on the manufacturer and no control over its quality. So for this, and also there may be high um, also there may be increased demand of urbanization, and we also venture the challenging side and building high-rise building. We need to improve the ground. So for this we use different techniques. That's why we study the ground improvement methods. Then we study the different types of geomaterial and what are the potential problems of this geomaterial. So these geomaterials I discussed based on the type that natural also by field. So in nature we study the soft, clay, silt, organic soil, loose sand, expansive soil, loose. So they are also different. They have different that's the potential problems like in soft soil. There may be possibility to low strength, high compressibility, large creep deformation, low permeability. Like silt also same similar type of problem are happen. Then we study the field. In field we study uncontrolled field, dredge field, reclaimed field, recycled material, solid waste and bio-based byproduct material. And also study the different potential problem of this field. And then we study. the bearing capacity geotechnical problem and possible cause. That means why this bearing capacity failure happen, why this large total and differential settlement happen, ground heave happen, and instability happen. So the reason is for bearing capacity failure is that applied pressure is higher than the ultimate bearing capacity, and also we study the what are the possible cause to happen when the bearing capacity why this bearing capacity failure occur. So we study that the high when we apply high applied pressure, also when we apply inclined load at small area, then bearing capacity failure occur. So also like that way we study different types of failure and the theory based on this failure. So it is very important for your exam purpose to remember. There may be some MCQ framed based on these points, and it is very easy to solve. You should just remember the main cause of or main theory behind it, and you can answer. Then also another types of problems like liquefaction, erosion, seepage, and here also given some cause why it is happened. Like liquefaction is happened when the effective stage becomes zero, and it like soil profile is behave like a liquid. So uh, so likewise seepage is occur due to the Darcy's law. You should remember it. It's very important. Then we study the ground improvement method for transportation infrastructure. So these are the different types of ground improvement method used in transportation infrastructure, mostly for improving the pavement. So there you can go through it. Then we study the classification ground improvement method based on different research and based on different criteria. That means by Mitchell, it is given by construction and function, and it is categorized ground improvement technique based on the in situ and deep compression of porcelain soil, then pre-compression, injection and grouting, admixture, thermal reinforcement, like that. Like that, Houseman also classify this ground improvement based on process, and here it's four types here. That is mechanical modification, hydraulic modification, physical chemical modification, and modification by inclusion. You can go through it once because that it is not much important. We elaborately study this. Now, here, based on our requirement, we divide the ground improvement technique in different ways, like shallow, complex, shallow ground improvement technique, deep ground improvement technique, chemical, physical, then water, hydraulic ground improvement technique, geosynthetic, like that. So, in shallow ground improvement technique, we most of the method use the over excavation replacement, and there may be some benefits also and some disadvantage also, and we can study also where this ground improvement technique is mostly applicable. That means the shallow ground improvement technique mostly applicable up to the depth 3 meter. You should remember it, and it is mostly improved by mostly uh, improved by remove the problematic geomaterial and replace with the good quality geomaterial. Then we study the other cell transfer technique like traditional compaction, then high energy impact roller compaction, the intelligent compaction, likewise. And you also study this. We also study the why where this ground improvement techniques is applicable, and what are the how it is applicable. That means traditional compression happen by apply static air vibratory roll on the ground surface at a certain number of passes. Then Then we study the densification. And deep densification, there are two types of densification happen: dynamic compaction and vibro compaction. And dynamic compaction, the depth of the improvement up to 10 meter, and it is mostly used for the cohesionless soil or granular soil, and silt percentage not more than 15%, or fine percentage not more than 15%. And in deep dynamic compaction, we study that heavy weight hammer is dropped at a height of certain height on a ground, and due to this height, potentially an energy is created, and it is impact on the ground, and this by this energy the soil particle is come closer, and densification happen up to a large depth. Vibrocompaction, we apply some vibratory force by some probe into the ground, and then we improve or the ground. And for vibratory compaction, the depth of the improvement is in between 5 to 15 meter. We will all study it there. And after that, we study again another type of deep compaction like sand compaction, column compaction, stone column compaction, likewise. Then instead of sand compaction, this depth of improvement is 5 to 15 meter, and stone column also depth of improvement is 5 to 10 meter. Then we study the ramped aggregate column, geosynthetic and case column, and we see that these are applicable up to a depth of 5 to 10 meter. So then we again classify this ground improvement technique based on the drainage, and in drainage we use the field drain and drainage geosynthetic. So we actually use to minimize the liquefaction possibility into the soil when the ground table is quite or close to the ground surface. So we by this technique we remove the water from the and lower the groundwater table, and also reduce the possibility of liquefaction potential. Then we study another other dewatering like uh, open pumping, then well system. So then we study the concentration method to improve the ground like field preloading, decom preloading, like this. To use this is used to increase the strength and reduce the settlement most of the case. We study shallow chemical stabilization, like chemical stabilization of subgrade and base widely. So, and this is suitable up to 0.3 meter. By name, it is itself, it is understand that it is the depth is not much, so it is up to 0.3 meter. Then we study the deep chemical stabilization like grouting, deep mixing. In grouting, it is very popular technique, and it by grout some good material onto the ground, and we create some hardened mass, and by this way we improve the ground. And this grouting technique is mostly used for the repairing purpose or temporary work of the construction. Uh, then we study the field reinforcement. Field reinforcement, this is divided by the geosynthetic reinforcement slope and geosynthetic reinforcement embankment. We in the previous class we also studied this, and in the last class, and we see that it is increase the stability of the slope and earthwork by inclusion of the geosynthetic material like geotextile, geomembrane, like this way. we improve the ground by inclusion in this geosynthetic material. We have some pictures given of this geosynthetic improvement by this geosynthetic material. Then we study the mechanical stabilized wall. In mechanical stabilized wall, we also solve some problem to find out the stability of this wall, and we also study the geosynthetic reinforced road. So you can go through this. These are the classification based on the uh, different functions, and we elaborate a study also. So, and we also show that one chart where this based on the grading purpose, soil particle size, which stress is suitable for what type of particle size. We see that shallow compaction is suitable almost all type of soil, and for chemical grout is mostly suitable for when the particle size is between 4.75 mm to 0.0715 mm. Like this way, different types of methods are given based on the different uh, particle size. You can go through it. It's very important. Then we study in our very beginning or in our first class the shallow ground improvement technique. First one is excavation and replacement technique. In excavation replacement technique, we study that when the depth of the problematic soil is very small from the ground surface, we can actually replace this problematic soil by a good uh, material uh, for this technique. So we can see that in this figure we actually excavate up to a certain depth, and then we replace this problematic soil by a good compacted material, and after that we use our construction on this soil. Remember that during this technique, the groundwater table should be below or much more below our foundation, like 1.5 to 1.5 uh, width of the foundation. From this level of the foundation, the groundwater table should be below this foundation. You should remember this. Then we study that up to this technique is uh, useful when the depth of the up to a depth less than 3 meter, and also it is we sh- uh, we study that whether it is mostly used, like it is used to eliminate the expansion sinkage type of soil, eliminate the freeze of frozen soil, and we study the advantage of this. You should go through it, and we also studied there where it is not uh, we can say disadvantage of this technique. So excavation and replacement technique are mostly not used in the when the groundwater table is very high. You should remember it. Then we discuss the principle of this study. We discuss the design consideration of this experiment replacement. Mostly to design, it is based on the task to find out the task bearing capacity, and we compare this whether this soil is capable to take this load coming from the structure. If it is okay, then no need to improve. If it is not, we replace this soil or apply good and compacted material. After that, we start our construction, and we study the different type of failure mode of this excavation replacement, like general shear failure, then punching failure, distributed failure, like this. And we also solve the one or two problem on this formula also. It is nothing but the Target bearing capacity formula, and all the values coefficients are given, and you should remember it. It is very important for your exam. They may be asked to solve or to find some coefficient. You should remember also this coefficient formula. And you should remember that at 0 degree, mostly they try to solve for the 0 degree. Phi is equal to 0 degree. You should remember this. So what are the value of C and what is the value of C when the phi is 0 degree? That means what you should remember, or sorry, what is the value of NC when the phi is 0 degree? Here it is 5.14 or phi is 0 degree. Most of the problems are based on this phi is equal to 0 degree. Also, you should remember what are the shape factor and depth factor when the phi is 0 degree. You should remember that SQ as gamma is 1 and DQ D gamma also 1 when the phi is equal to 0 degree. You should remember that. Then in week 2, please wait, it takes long time. Sorry, there may be technical problem. Please wait few minutes. Yes, it is come. So in week 2, we studied the shallow densification, and it is mostly based on the uh, uh, compaction test or compaction. We can say light compaction, heavy compaction. That means simple Proctor test or modified Proctor test. So we study the principle of this shallow densification. In principle, it is said that we apply the some mechanical energy. Due to this mechanical energy, we expel out the air from the void space, and void may get reduced, and the soil grain come closer, and densification takes place. So then we studied the equipment used to in this shallow densification. There are different types of equipment like roller, deep hip foot roller, smooth wheel roller, pneumatic roller. Like this way, we study the advantages, limitation of this study. You should go through it. It is very important, and this formula also very important. We solve some problem based on this formula to find out the mix dry density, and which is based on given by if given bulk density and water content. Here is given one maximum dry density versus moisture content curve, and you can see that there is theoretical curve is due to airborne line. It should be parallel to the lower side or right side of this curve. You should remember it. And this left side of this curve is called dry of optimum. This right side is called weight of optimum, and there are some benefit. And you should remember this when we use dry of optimum moisture content and when we use weight of moisture content for hot type of soil. And here one curve also given based on the different based on the energy. So if we see that if the number of row increase, curve is move upward, and also the water most optimum moisture content is line is shift left side. You should remember this. It is very important that when we apply more energy, the curve will shift upward, and also the value of optimum moisture content is shift left side. And also, this one graph is shown for based on the different types of geometry. Like for oil graded soil, the high curve is given highest curve. At plot, the curve is at highest, and also it requires the low moisture content. You should remember this. If the material, good material require give the maximum density and also require the less amount of optimal moisture content to reach this maximum dye density. See that different type of mm, curve is given for different type of uh, energy. So then we study this the influential factor of this shallow densification, and there are maybe different types of influence factor like the types of geometry. It depends on types of geometry, moisture content, compaction method, compaction effort, then including applied energy, leaf thickness, number of passes, relative density or stiffness of this layer. So we study all of this, also solve some problem. Then there is given for what type of geomaterial we can use, what type of machine like rock fill we use, vibrator roller to densify the soil. So we also for plastic soil, which are high compressibility and high compressibility, we use hip foot roller. We for clean sand we use vibratory roller. You go through this table. It is very important for your exam purpose. There may possibility to come some MCQ. And one thing you remember, what are the problems I'm discussing here? That means mathematical problem. You should go every problem because the majority of the question are framed based on this problem only. And you should remember this technique how to solve this problem, and one by one go through it, and it is very simple. uh, 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 these problems are very simple and nothing any exaggerate, so you can go through it and also go through the formulas whatever discussing here, and the tables are given for based on different requirement. You can go through it and you can easily answer the questions given in the question exam. So, so you you see that there are again the different types of equipment given and what are the application or applicability, and we can say what are the suitability of this use of this equipment. You go through it like this. One problem is given. We solve this problem in our class, and also I think also I'm upload this problem solve problem on my Google Drive. Let's go through it, and then week 3 we discuss about the uh, deep dynamic compression, and there may be different types of deep dynamic compression like dynamic hammering, likewise. And we also discuss the disadvantage, disadvantage. So in deep dynamic compaction, we drop drop freely a weighted mass on the ground at a certain height, like height is like uh, 10 to 40 meter, and the weight of the mass is 5 to 10 ton up to, and then that create some vibration at the ground, or due to this vibration the material is come closer and densified, and this densification is take place up to a depth of 10 meter. So it is mostly used, this technique mostly used for the questionless, so you should remember it. Then we also study the suitability of this technique, that the seal percentage, that means persistivity index should be less than 8, and this technique should not useful for the clay soil. We for clay soil we use different types of technique. You should remember. and we study the adverse situation of this dynamic compression. It is mostly based on that when the ground water table is very high, we cannot use this technique. And also, if the field material, most of the field material is clay, then also we cannot use this. We need to adjust something else. Like this way, different adverse situation are given. You can once go through it, then advantage, disadvantages of this technique. It is very simple technique. Nothing here is very difficult. So, and due to this dynamic densification, dynamic consolidation happen, and this dynamic consolidation is mostly used for the clay soil, because in clay soil when we apply energy it takes times to dissipate the water, and after that it regain its strength. So we can say it is a dynamic consolidation. And here you can see that for dynamic consolidation, when we apply the energy, first trial, then immediately the volume get changed. After a certain period of time, volume get constant, reduced. At the same moment, degree of liquefaction is reduced and bearing capacity increase. Here the some procedure given in schematic diagram. First we apply this load up to a certain height and create and drop at a free fall drop at the ground surface, and due to this there some depression happen. And after that to fill this depression some good material, and we can compact again by this uh, geomaterial, so again compact by this uh, heavy white heavy hammer, and surface is smooth by the normal shallow compaction machine like smooth wheel roller, shift foot roller, like this. Then we study the dynamic replacement method. Actually, to before applying this deep dynamic densification, if there is any compressible layer is present, we can replace it with some wood material, and then we apply this heavy deep dynamic compression method by damping. Then we study the some design consideration. We take the uh, sorry for that. My network is very. I'm again showing my uh, slide. Please wait. Yes, I think it is now visible to everyone. Yes, we're discussing the design consideration of deep replacement method, and it is based on the different geometrical, particle size, fine content, and also ground water level, and possible voids like that. You should remember this. You try to remember. No need to you apply your common sense, because it is very easy to understand when in most of the geometrical ground improved technique is used for uh, Sorry for that. Yes. The yes. The most of the geometrical design procedure is based on the geometrical type, ground table presence, and also the whether the sensitive soil is present or not. You should remember. You need not remember that much. You just go through it once. Then, uh, what are the influence factor to govern the deep dynamic compaction? Like it is depend on geometrical type, depth of and area improvement, tempered geometry, weight, drop of height, pattern and spacing, then uh, environmental impact. Uh, Also, it is depend on presence of soft layer, presence of hard layer, like this way, different influence factor. It is governed. Then, like soil types for deep dynamic compaction, the soil type is categorized in three based on based on pervious, semi-pervious, and semi-pervious. In semi-pervious, based on plasticity index less than 8, plasticity index greater than 8, like that. Then we design the deep dynamic compaction. First, before designing, we first go to the depth of improvement, how much depth we require to improve based on our height and weight of the hammer. So it is find out by some empirical formula, that is di is equal to nc into root over wt into hd. Wt into hd is the energy applied on the ground, and it is you should remember that this term is given in ton meter. So before solving the problem, you should consider the units of this term, and nc is the some constant, and it is given on the problem. And this technique is, and the depth of improvement is for sand is up to 10 meter, and for cohesive soil clay is up to 5 meter. This is very important. It is, you should remember it. Then here it is given NC value for different types of geometrical type and degree of saturation. That means for pervious soil and high degree of saturation, this is NC is equal to the zero point 0.5. And here one empirical formula is given to find out the drop of height, height, height of drop, and it is given is that WT into HD to the power 0.54. You do not confuse here, because here in left side also one HD, and right side one HD. But it this right hand side uh, WTHD is given as a energy purpose. So if in problem there may be given the energy applied in this into the ground in ton meter, and you put it in this formula in place of WTHD and get the uh, height of drop. And this height of drop is mostly between 10 to 40 meter. And then we study the pattern spacing of this deep dynamic compaction, which which in which in pattern spacing we compact different phases. First phase in at a larger spacing, and at second phase is at a smaller spacing. Because you can see this picture, this energy is distributed at a first we improve the ground at a larger depth, so the spacing should be large, so the energy distribution should be larger. But uh, after that, we improve the ground, which is close to the ground surface. For this, we decrease the spacing, which is called second phase 2, and improve the ground uh, very close to the ground surface. After that, for smoothing, we use or we leveling. We use the irony pass. Irony pass is based on the smooth roller seafood roller like this. We find out the depth of crater. Depth of crater is the depth created due to the impact of the hammer, and this depth of crater should be 1 to 1.5 meter, because after if the depth of crater is very high, then this technique is not suitable, because it is the handling of this weight, heavy weight, is very difficult if the depth of cutter is very high. So by this formula, uh, first one you should apply the first one, and first one is based on some empirical formula. It is approximation. uh, it is given some approximate value of this type of cutter, and most of the case we use this first one, because the second one is very critical and difficult to remember, and also usefulness of this second formula is very less. Then we find out the applied energy for every pass and drop. So you can see that uh, this applied energy is required as some when we apply this drop, there may create some influence area, and this influence area uh, is depend on the pattern of this side. That means this equivalent influence area for square pattern is equal to the spacing square, or s square. S is the spacing in between two drops, and for triangular pattern it is 0.867 square s square. We then study the unit applied energy, and it is based on the depth of improvement, and this unit applied energy, by this unit applied energy we find out the how much depth we need to improve. We consider it by some given table, like for pervious material this unit applied energy should be in between 200 to 250, and for semi-pervious soil it is in between 250 to 350. For landfill it is in between 600 to 1100. You should remember that for stronger material the applied energy required less. For loose soil or problematic soil, this applied energy required more. You should remember. We also solved some problem based on this, and you can go through the design criteria of this technique, and induce settlement up to how much. That means for different types of uh, soil type, this technique for different types of soil type. Uh, Up to how much depth this technique, or how much soil uh, settlements happen, percentage of settlements happen. That means for natural care, the percentage settlement should be in between 1 to 3%. For uncontrolled field, the percentage settlement should be in between 5 to 20%. Like this way, you should do and remember, or do while conducting this test. Then most important is to term is the peak particle velocity. which by this formula we find out the environmental factor, or we find out the vibration in particle. So if the peak particle velocity is more, then there may be possibility to uh, yeah, occurring the vibration. So this you should by this formula, empirical formula, we find out the peak particle velocity, and you should remember that for commercial wavelength, the peak particle velocity should not be greater than 20 to 40 per second. For sensitive side, its peak particle velocity should not be greater than 3 to 5 per second. So here, given the procedure of this technique, we first prepare the gown, then apply some leveling instrument, how much depth we require to improve. Like this way, we that may not be come in your exam. You should remember the design procedure, design step, how to design this pattern, and why it is used. And we solve this problem also. One problem, big problem. It is very big problem. And it is very important to your exam, and you, it is you can go through it. So a very big design problem. In by this problem, you can expect uh, a small portion of in your exam. So you go step by step and try to solve by yourself. Then in week four, week four, we studied the rapid impact compaction. So it is similar type of deep dynamic compaction, but here the drop of height is 1.2 meter, and the weight of the hammer is 5 to 12 tons, and it is improved the ground uh, up to a depth 5 to 6 meter, and also it is very quick to improve the ground, and it is generate 60 to 40 to 60 blocks per minute. And we study the suitability. Most of the case it is suitable for granular soil, and improve the ground up to 6 meter. We study advantage, disadvantage, design consideration, and it is similar, and also study the pattern types, like means square pattern, triangular pattern, a tertiary, and pattern is scaled down in primary, secondary, tertiary. In primary, the spacing is very large. In secondary, we reduce the spacing, or we can improve the ground in between these 2 points. In tertiary is the trial, is the last one. We further reduce the spacing. And again, same formula is used to find out the applied energy, which is find out in deep dynamic compaction. Also, by one we find out take care of the environmental impact also by finding out the peak particle velocity through this empirical formula. So, by this formula, we also solve some problem, and this problem I uploaded in my Google Drive. Please go through it. Here, this formula. The solution is uploaded to the Google Drive. Please go through it. Construction procedure. You should go only the problems and the formulas and why it is mostly used, and also go through the different tables which is given for different types of functions. One by one, you go through it. Now we come to the vibro compaction. So before we start our vibro compaction, we take some break. After that, we continue our session and conclude it. Very, very quickly, we conclude it today. We just go through once slide by slide, and uh, like that way we finish our session. So, hello everyone. Now we complete our remaining portion. So, in week 4, we study the vibrocompaction in details. So, in vibrocompaction, study five basic concept of the vibrocompaction. In vibrocompaction, we drive one vibrating probe into the ground and create the vibration. And due to this vibration, the particle to particle friction or attraction is breakdown, and particle may come closer. And due to this, densification happen. So we can see this picture also. There's one probe is driven, and after that vibration created, and there may be some void place is created due to the vibration. Particle may get closer, and we put some good material on it and improve the ground. And this vibrocompaction is suitable for densifying the deep deposit of coherently geometrical with up to 20% height, but less than 2 to 3% clay. Yes. Then we also study the different zone uh, which is best for this vibrocompaction. The, we see that zone B, which is more suitable for vibrocompaction, and it is belong to coarse to medium gravel. Coarse and to medium gravel. Application, advantage, disadvantage, mechanism is like that. We use this vibrocompaction and generated some food, and this food, uh, this if the acceleration or vibration acceleration is greater than zero point 0.5 g, then only particle to particle force is backed down and compaction takes place. So, due to this vibration, four zone is created: dilatory zone, fluid zone, compaction zone, and elastic zone. And it is based on the uh, particle to based on the acceleration. If the acceleration is greater than zero point 0.5, then only this type of four zone is created. So, elastic zone, most of the vibration and so densification, most of the densification takes place in between the in the at the border of the fluid zone and compaction zone. Uh, so we should remember this. So I think my presentation is yes. So mm we also study the surface densification for deep densification, deep vibration, surface vibration. And I see that the surface vibration is create less amount of densification than the deep vibration. And we see that one theory to find out the settlement or volume of change without backfilling. So by this formula, S by H is equal to E naught minus C1 divided by 1 plus C1. We find out the volume of the soil required volume change without backfilling. S is the depression. H is the height of the layer, thickness of the layer. So in Fig 4, we also find out the volume change without and also backfilling we and also find out the spacing for different square pattern triangular pattern for this, and then we find out the volume change with the backfilling. So by this formula also find out the spacing for triangular and if square pattern. You should remember this formula. It is helpful to solve your uh, exam problems, and most of I think most of the problem is come from this basic formula. So and also there are some uh, also there are some by this formula assignment also some problem is given by this formula. If you try to solve this, all the before going to exam, you try to solve all the assignment problem of this year. Also try to solve the all the problem questions in previous years also. Uh, so for your better understanding and also try to score better in your exam. I am uploading the previous year questions in my Google Drive. Don't worry. I am uploading all these previous year question from week 1 to week 12. Uh, don't worry about this and try to go through every assignment just once. If you try, uh, if you think that it's very difficult, first go through the slides, uh, very specific up to then after that we will go through these assignment problems. It's better for your understanding. And also we study the different types of influence area, compaction point, a vibration point for different types of foundation. If the foundation is very small, then two or three compaction point are needed. And you should remember that the foundation area should be fully covered by this compaction point or influence point. Grid pattern, spacing, and this grid pattern and spacing is depend on the relative density. And we also solve some problem based on this. And this formula is given by the when the volume change with backfilling. Study the design parameters for vibrocompaction, and it is depend on geometrical types, fine content, percentage of clay particles, thickness and depth of the problematic material, depth of groundwater table, initial void ratio, relative density of the material, target void ratio, then pattern spacing, area of improvement like this. There's some explanation also given for this. We'll go through once. Then equivalent radius square for square, equivalent radius is equal to the 0.564 for triangular, the equivalent radius is 0.525 into spacing. Uh, you remember this too. It is very useful to solve the problems. One problem also is solved based on this formula only. And here one design problem also given based on this vibrocompaction and particle size is refined content is given. All this solution are uploaded in this Google Drive. Week-wise, we go through. Every week, I am uploading some problems. So we go through it. Then quality assurance, quality control, when it is required. Then we study the deep replacement. So it is similar to the vibrocompaction. So in vibrocompaction, nothing. We not replace the problematic soil. Soil. But in dip replacement, we first remove the problematic soil at a depth and apply good material. After that, we apply some vibration force and we compact the ground. There are some basic concepts given. So you see that we use some this vibro replacement. There are different type of vibro replacement like vibro replacement, vibro displacement, vibro concrete column, control modulus, stiffness column. All of this theory actually taken from one book, Principle of Geotechnical Ground Improvement Technique by Hassan. And so we can go through this book. Sorry, I think the book name is this. I think the book name is yes, Houseman, Engineering Principle of Ground Improvement, Houseman. Also, the Principle and Practice of Ground Improvement by J.N. Ham. Really, you can go through these books. Every problem, every theory is taken from this book. So here some deep replacement is again categorized by dynamic displacement and also replacement. So uh, this removal is take place by injecting water, also by drilling hole, and then take out the problematic soil and replace by the good soil. And displacement is take place by the injecting air, by driving steel casing, by driving reverse flight, by dropping a temper like that. As suitability, it is based on the different particle size. Vibro compaction is mostly suitable for the portionless soil. That means from gravel to fine grain sand, up to fine grain sand. And the vibro replacement method mostly suitable for this fine grain sand to clay soil. And this vibro replacement technique is used improve the soil after depth of 10 to 15 meter. Advantage and disadvantage of this vibro sand compaction columns or stone compaction column. So by this vibro replacement, we use two types of we can create two types of column. One is sand compaction column and stone compaction column. The sand compaction column we use sand to replace the soil, probably soil. Stone compaction column we use small stone like gravel to replace the problematic soil. And there may be some difficulties and also advantage. We can go through it for different types of soil. So now for stone compaction column, we study the load transfer mechanism. That means stress versus equal stress versus equal state. So in equal stress, the stress between the soil also in between the stone column is equal, and equal strain method the settlement between the stone and soil is equal. So here and based on our requirement, we that means use different types of method. So the equal strain condition happen under rigid loading, while the equal stress method is happen under flexible load. So you remember this. Rigid loading means rigid footing. Flexible loading means tire pressure. So by this way we solve our problem. So here stress concentration ratio is given, which is given by the ratio of the stress on the concrete on the compaction stone column and to the stress uh, is created on the surrounding soil, and which is also further equal to the uh, modulus of constant modulus dc by ds. Constant modulus of the stone column was divided by the constant modulus of the surrounding soil. Here some formula given to find out the stress in between these columns and surrounding soil. And here it is given the different failure mode. It is failed by some bearing, also failed by some skin friction, bulking, and the buckling is happening in between the 2 to 3 DC, where DC is the diameter of the stone column. You go through it. This is very important. It may be asked in your exam. Tell the different types of failure mode. The first one is failed by the crushing. If the material strength is less, then it is failed. Second one is failed by bearing and bearing. Third one is failed by the skin friction. The fourth one is failed by the buckling. Then week 6, we study the drainage. So there may be different types of drainage technique we use uh, to like drainage, dewatering, bear. So drainage mostly used to expel out the water from the ground and reduce the lowering the groundwater TB. So it is useful when because due to this water, pore water pressure is increased and efficacy stress reduced, and there may be possibility to happen liquefaction during this earthquake. So we go through once different type of drainage is happen granular drain, then synthetic drain, combined drain. We go through once and by the application of this drainage like trench drain, pavement drainage, retaining wall drain, chimney drain, which is used for dam, then vertical drains mostly used for compressible layer, compressible soil, then inspector drain or toe drain, inceptor drain or toe drain. Advantages of this drainage technique, limitation of this drainage technique, we go through once, then dewatering, dewatering to expel out the water from the ground by some pumping tests like some well points, deep well points, electroosmosis, dewatering from soil, and there may be some advantages or disadvantages of this technique. We must go through these points and pattern spacing required to for this dewatering during pumping out of this water, and uh, there may be two types of dewatering is happening. One is deep dewatering, another one is shallow deep dewatering. So for deep dewatering we use deep wells with submersible pumps. For shallow dewatering we use well points for different depth, stage 1, stage 2, stage 3, and this is sometimes we use the deep wells with auxiliary vacuum system also. We use this. Then electroosmosis. The pattern of the electroosmosis we just once go through, and then there may be suitability guidelines for different types of dewatering techniques. Like some it is dewater up to 1.5 meter for deep conversion point. The dewater is going up to 5 meter. If for further dewatering, we require multiple stage oil point up to a certain depth. Stage wise, stage one, stage two, like for deep dewatering, we use vacuum well dewatering, which is also up to 5 meter. Then jet eductor, well point, deep well system, electrostasis. These are the technique we use to dewater from the ground. Then suitability based on the particle size, and this chart is shown for which technique is suitable, which deodorant technique is suitable, what type of material. You see that for uh, particle size from 1 to 1 to 0.001, most of the gravity drainage deodorant is used, oil point is used, also electroosmosis is used. You once go through this chart. Then the application of this dewatering technique to control the groundwater, just, and also we study the advantage limitation. Limitation is that while dewatering, we check the adjacent structure because due to this dewatering, effective stress increase because pore water pressure reduce. Due to this effective stress, the soil to particle may come very closer and settlement is happen. If there is any presence of an existing structure, there will be possibility to collapse due to this settlement. You need to check when applying this deodorant technique. Here one formula is given to uh, possible uh, to deodorant pump to take this deodorant technique is used for unconfined and also confined aquifer, and by this way we find out the discharge of this deodorant, and we study, and this deodorant is mostly based on apply based on the Darcy's law, and by this way we find out the different discharge area of this oil points, height of this oil point, then thickness of this oil point, and find out also the permeability required for this oil point for different types of aquifer. You once go through this formula, just remember this formula once, and then we can try to solve different problems based on this. We should also solve this problem. Also study the drawdown curve. Mostly like this way, drawdown curve is like this way. It is like parabolic type of curve is created around the well point. If we use two well points, most of the use the well point in two well points uh, mm, at surrounding the construction site, so it is easy to draw down the water table. Then multi-well system, we find out the combined discharge of this multi-well system. Then equivalent circular well multi-well system. We go through and try to solve this problem. This solution is given on my Google Drive, so you can solve it from here by this reference. And in week 7, we study the consolidation, basic concept of the consolidation. Please go through all the basic concept for every techniques, and what are the major principle of this techniques. Like pre-consolidation, we actually uh, consolidate the soil before the construction up to a certain settlement, uh, so that before after construction there may not be possibility to settle further. So we study the pre-consolidation, which is depending most of the structure, weight of the structure, and also the type of the soil. And most of the case is used for the clay soil, or we can say impermeable soil. And to increase we accelerated the dewatering due to the spill loading, pre-consolidation. We also sometimes use the vertical drain, sometimes sand drain. So due to this, the drainage path is increased, and also increase the or reduce the time of consolidation. So for you should remember some uh, uh, properties also of this drain. That means this drain should be the diameter of the drain should be in between 300 mm, and should be in between 300 to 600 mm, and the spacing is in between 1.5 to 4.5 meter. The pattern, spacing, triangular pattern, square pattern, you need to remember. Then application of this preloading, like it is mostly used for highways, airports, land reclamation, storage tank, building advantages, limitation. Then find out the settlement, which is also called strain effect, and the settlements find out the MV, coefficient of volume change, dp, the change of stress, and into H. By this formula we find out the settlement during the pre-consolidation. And to find out the consolidation, degree of consolidation, we use the consolidation theory in three-dimensional consolidation theory, because when we use the vertical range, the consolidation drainage path is take place due- at the surrounding of this vertical range. So, so we use the three-dimensional consolidation equation. S square R is equal to pi r square. Actually, we find out the equivalent radius of this drain, and it is similar to the pattern we use in deep dynamic compression, repeat compression. So, equivalent radius is equal to the 0.564 into A is the spacing between the two mm, drains. And for a triangular pattern is equal to the 0.525a. If by this formula we also solve some problem. And if I for find out the time factor for consolidation, and it is also find out by formula ch into divided by 4r square. 4r square means diameter of the yes, two diameter of the drain is 2r. If you square it, it will become 4r square. Uh, it is for radial drainage consolidation. And by this chart also you can find out n is the uh, n is here is so n is the number of drains. I think, hey, yes, sorry, n is the ratio of the radius of the influence area to the radius of the drain. And based on this n, we find out degree of consideration versus time factor. If please go through once these formulas and try to solve this problem. And solution is given to, and also here also given solution. So try this problem once. Then the- again for efficiency, increase the efficiency. Beside sand rail, we use prefabricated vertical drain. And prefabricated vertical drain, uh, while using the prefabricated vertical drain, we use one formula to find out the diameter, equivalent diameter of this prefabricated vertical drain, which is equal to the 2 into a plus b divided by pi, where a is the length, b is the width. So, so by this formula, we find out the equivalent radius. So, and after that, we solve the problem. And after that, we apply this in our consolidation theory, because this consolidation theory is based on the radial or use. The consolidation theory is based on in radial direction. So we converted our preferred vertical into in circular drain. So then we apply this consolidation formula, and find out the degree of consolidation and time factor. Here formula is given. When the time factor is less than 60%, formula is equal to the t is equal to the pi by 4 into degree of concentration square. When the time factor is greater than 60%, t is equal to 1.781 minus 0.933 log 10 into 100 minus degree of consolidation. So, and also solve one problem also here. So go through this problem only. Nothing. If you solve this problem in PC concentration, it is enough. Here is the problem. Also solution is given. Go through the problem and then design step. What are the design steps, or what are the factor we need to consider while designing this? You once go through this, and then different type of, if you create a particle then like this way we have given, no need to remember. You just once go through there, and then please wait. Then to find out the consideration, we need to consider the peak consideration stress, over consideration ratio, coefficient of consideration both horizontal and vertical direction, coefficient permeability both in horizontal and vertical direction, diameter of the smear zone, permeability of the smear zone, like this. Then field monitoring and performance of this while conducting this peak consideration. Then Then in week 8, we study the grouting. So in grouting, we inject some slurry into the soil, and after that, this slurry become hard, and hardened mass is created, and increase the strength and decrease the compressibility and permeability. The mode of grouting, how differently we use this grouting, like permeation grouting, compaction grout or displacement, controlled displacement grouting, hydraulic fracturing or uncontrolled displacement grouting, compensation grouting, jet grouting. Here some figure is given for different types of grouting, objective of grouting, suitability of the grouting. Then here on also chart given based on the particle size. We see that for jet grouting is almost use all type of soil. So it is better to use jet grouting uh, for all type for our if we need to construct if we need to apply the grouting technique. Then application of the grouting, like densify the granular soil, raising the settlement structure, settle structure. That means if that means prepare repairing purpose. That means if the some existing structure is settled down, we can applying the grouting. We can raise this structure. We can use then settlement control, underpiping of the existing foundation, excavation support, protection of the existing structure during tunneling, liquefaction mitigation, water control like this. The advantage of the grouting, limitation of the grouting characteristic. This means that most of the grouting are depend on the groutability, stability, setting time, permeance, and toxicity. Groutability means uh, that means groutability is defined by the groutability ratio. That means diameter of the size of the particle, which is at 15% passing or finer than soil, and the size of the grout, which is at 80% of finer. By this way, find out whether grouting is required or not. The stability, setting time. That means uh, late setting causes the grouting being washed out. If the seepage is occurring, early setting causes difficulty of the grouting reaching its destination. So the setting time should be in between like that. That it is not very early, also not very late. Then we need to consider the toxicity material used in the grouting. So because if we apply, if there is the granular table is very close to the our application, then this technique should be avoided because some toxic material is used in grouting. Then grouting material is defined based on the different function like suspension, emulsion, solution. So the suspension is used when cement plus water is used. Also some clay plus water is used. Emulsion is used on asphalt or bitumen used with water. Solution is used with chemical grouts. Then unsuitable for cracks or the suspension ground, there may be some requirement. We should need to go through it. Like it is unsuitable for crack or void wider than 0.2 meter and mostly used OPC, ordinary Portland cement plus water, and the water cement ratio should be in between 0.5 is to 1 to 5 is to 1. If you keep remember these terms, all the specification is given for different types of grout. Then there is then grouting plants and equipment is here one figure is shown. Then types of application of the grout, different permission grouting, where it is applicable, suitability, compaction grouting, where it is suitability, and jet grouting like this. Then uh, the jet grouting mostly used to control the groundwater table, groundwater control. Then also used for groundwater movement, ground movement. Also used as a support. Used as an environmental also use. We need to consider this. Then soil fracture grouting and different application and the theory of injection, the amount of grout, how much amount of grouting is used. It is based on the Darcy's law. To find out the height of pressure used while using this grouting, then influence area of this grouting, then permeability of this grouting material, time taken to uh, reach the targeted point, and by this formula we also solve one problem also, and compaction grouting have some theories given. You can also skip this, but you should remember the direct formula by which is which is used in uh, used to solve the problems. We should remember this. And changes percentage change of the unit oil. We should also remember the pressure required to for jet grouting. You remember the formula directly for this. We can you use the you try to see the problems which I am so which is solved in your class, and by this formula just it keep also solve the assignment problem by this formula. By this problem we and which formula is used to solve this problem, up to that much formula you can remember. You need to go through every step by step, so or also derivation of this formula for exam purpose. Then design consideration for formation routing. For designing, we need to check the routability. For it is said that for soil, for clay soil, the groutability sorry, for any type of soil, the groutability ratio should be greater than 24. For clay soil, the groutability ratio should be for clay cement, groutability ratio should be greater than 5. You remember this. For rock, for if you use the cement grout, the groutability ratio should be greater than 2, uh, or we can say for consistency result, groutability ratio should be greater than 5. Head pressure head required while applying the grout, then grout pressure required. Also, we find out the time required to reach the targeted point by this formula, and also solve some problems. You should go through every problem. Then in week 9, we study the chemical stability, we study the soil stability, the chemical stabilization, need for the chemical stabilization. Then we most of the case chemical stabilization happen by the lime, where we use the quick lime, lime clean dust, hydrated limes, and also for chemical stabilization we use cement, class C fly ash, class F fly ash. Then use treatment with lime. like by drying, modification, and stabilization. And lime you use for drying also you can use modification, lime, stabilization. You go the principle or the procedure of this lime stabilization, then chemical exchange also you can go through lime benefits of this lime for them construction of lime base. Here some figure is given. Then type of soil for chemical stimulation, which is suitable for chemical stimulation, we can go through. Then mechanism of chemical soil stabilization with lime. Here is procedure is given, reaction is given. We try to remember this. Due to the equation line, there is one material you created, which is chemical calcium silicate hydrate and calcium aluminum hydrate. And these two material is has a is used as a binding material, or we can call cementitious material, which is further used to uh, as a bonding between the particles. So you remember these two terms. Then the factor affecting factor used for light stabilization. It is used. It is depend on the soil type, lime content, compaction, curing type, admixture. Here some further explain this all one by one. We go once. Then stabilization, success with cement. So strength, permeability, volume, stability, durability. These are the controlling factor while using the cement stabilization. Soil stabilization. It's a mechanism of the stabilization, similar to the live stabilization also. Then building of soil cement, mixing, mixing in place mixing, so curing, compaction, mixing, spreading cement, cost, concern of using the lime sim and cement stabilization. You should remember because it is both are toxic in nature. While applying to stabilize the ground, you should remember some point like if the ground water should be below, much more below our targeted point, and also uh, the while using the there may be precaution is take some precaution is required while applying these chemicals. Then you also use the fly ash as a chemical stabilization because it has also some cementation as nature in nature. So we use this to improve as a replacement of soil, so cement. Also use with cement also, so the requirement of cement get reduced and it may be cost effective. So in week 10, we discussing about the soil name or anchorage. So we studied the soil nailing, uh, like different types of soil nailing, grout nailing, self-drilling nails, jet grout nails, helical nails, driven nails, shooting nails. Then we study the force acting suitability of the soil nails. Then study the where we cannot use the soil name. We also study like dry and poorly graded coarseness soil. We cannot use this soil with high ground water table, we cannot use this. Water rock with weak planes, we cannot use this. We should remember this. And then application of this soil name, advantages, disadvantages, then different type of failure mode. It is very important for your exam purpose. Like first one is internet failure. Internet failure like pull out failure, nail cell pull out failure, bar rod pull out failure, nail tensile failure, nail welding and shear failure. Just remember the names. External failure, we study the compound failure, sliding failure, global failure. Global failure happen when the base is failed. Sliding failure is happen when the horizontal force uh, is greater than the resisting force. Compound failure is happen at the toe of the wall. Then face failure, like flexural face failure, facing punching shear failure, headed start failure, that means connection failure. There are some stress distribution curve or force distribution curve is shown based on the uh, distance or failure surface. We go through it, see that there may be defined as active zone, reduced resistance zone. So active zone is defined the failure zone, and resistance zone is defined than the uh, good soil or contact soil. If we apply soil name, the force distribution like that, the shear stress in active zone is towards the uh, face of the wall. The shear stress in resistance zone is the outer direction of the, or again opposite direction of the face of the wall. Then different types of wall we can see here: MSW wall, mechanically stabilized wall, soil laid wall, anchor wall. For different types of wall, there is different types of pressure distribution. For this, we use different types of arrangement, and we see that formulas and some basic consideration, design consideration. That means each soil length has an influence area less than 4 meters square, and the spacing of the soil length is 1 meter, and minimum length of the soil is 0.5 h. The diameter of the soil is 100 to 200 mm. And we solve by these formulas. We solve some problem also. You directly go through this problem and try to remember this formula used in this problem. The chart are used to finding out the normalized values of this mu up, where mu up is equal to the tau u dp Fs divided by Fspu, gamma SSHP. All of these are discussed in our class. Please go through this. Then we discuss the soil anchor, similar types of the soil needling, but the failure mode is different. So soil anchor, basic concept go through, and suitability you can go through, application, limitation, and then advantage. So pressure distribution, load distribution mechanism, load transfer mechanism. So the basic concept is that in the soil learning, the load distribution is happened uh, also in between the active zone or failure zone. But in anchor, the load distribution is occur only in the good soil, not in the active zone or failure zone. So we should remember this, and there may be different failure modes of anchorage, like tensile failure of tendons, pull out failure of grout, pull out failure of tendon, failure of wall in bending, failure of wall due to sufficient passive activity capacity, failure by forward rotation, failure due to the insufficient axial capacity, failure by overturning, failure by sliding, rotational failure of ground mass, and also some problem or specification is given in our class. Please go through this problem. Then come to the week 11, we study the geosynthetic and ground improvement. In this, we study the different types of geosynthetic material like geogrid, geotextile, geonet, geocomposite material, geomembrane, like this way, and also study the application of function, different function use, the function of geosynthetic, like it is used as a displacement, used as a filtration purpose, separation, drainage, erosion control, barrier protection. So also study the different load transfer mechanism while using the as a reinforcement, then failure modes, separation as a separation, filtration, drainage. Please once go through it, and barrier protection, erosion control as a erosion control. Then used as a road. Mostly this geosynthetic material mostly used to as a road and pavement. Also used as improve the or stabilize the embankment. So you please go through this. Then in previous week we also discuss everything. Then we use the geosynthetic material to create the mechanically stabilized wall like this, or mechanically stable, mechanically for as a rhythmic wall. I also study the benefits using these geosynthetics. Basic concept of this mechanically stabilized wall, study the failure mechanism of this mechanically stabilized wall like this, where load transfer mechanism, active earth pressure theory, like Rankine theory, Coulomb theory, and this active coefficient earth pressure. I also try to solve one problem also in the next class. Sorry, in the week 12, we also solve one problem based on this mechanically stabilized wall. There some specification is given of this mechanically stabilized wall. You go through once, like design procedure of this mechanically stabilized wall, creation of the wall. After that, we also study the slope stability of, here is the problem of the mechanically stabilized wall. You go through this and try to remember the formulas which is applied in this problem. Then we study the uh, geosynthetic material used as to stabilize the slope as a reinforced slope. Study principal reinforced slope, types of reinforced slope, and the different types of spacing based on the different types of soil type and face angle. We can different failure mode. So we go all of this and try to remember as much as possible. And now stop our session here. And this is the last session. So I stop here. So if please before going to exam, please go through every assignment problems this year also solution this year also and previous year also, and I upload the all this thing in my previous year assignment problem in my Google Drive, and try to remember the formula which is applied in this problem, and also uh, try to remember the principles of these different geosynthetic sorry geo grounded movement technique and its application, suitability, and advantage, disadvantage, design procedure, and solve some and solve this problem. Uh, if this is our last class, uh, uh, after that, I think there your exam, I think, start from 22 October. Before after 22 October, so please prepare for this. So now I'm stop here. Thank you for being here and attend these classes. And today is our last class, so I think it is very helpful to everyone uh, while choosing this course and go through this course. So, and I am grateful to uh, take your class, this longitudinal class, and also thanks to Professor Dilip Kumar Vaidya sir to conduct this course. It is a very great course and very simple course, and it's not very simple, but how sir is created this lesson, it is easy to understand for everyone, and also uh, the problems sir discuss, and I am also give some inputs. It is very useful for you in your exam, also in your uh, further uh, uh, life. So please go through this slides first, and do not remember anything first. First go through every slide, then try to solve assignment problem. And if you start one, then come again the slides and try to remember these formulas and like this, and you can easily understand the facts. So now we stop here. So thank you everyone and good night. Hopefully, if I am taking this course again, hopefully we will meet again. So thank you.